going to start looking at the vocabulary of algebra. So we're going to get some of the basic words and vocabulary down. You can always refer back to this handy-dandy guide in case you ever forget what some of these words mean. So here we go. We're going to go through these one at a time. Start with absolute value. Absolute value is a function, and we'll talk later about what a function is. But it's a function that calculates the distance between an expression and zero. This will always produce positive answer because distance is not negative. Like for example, if I asked you, how far is it from your house to the mall? You would tell me, oh, it's 10 miles. If I then asked you, how far is it from the mall to your house? You wouldn't say negative 10 miles, you'd still say 10 miles. Distance is something that we count, and so it will not come out negative. In math, that means if I have the absolute value of x plus 2 equals 8, it means that x plus 2 is a distance of 8 units away from 0. This number after the equals with an absolute value is the distance. So if I tried to make it negative, that wouldn't make sense because distance can't be negative. So x plus 2 in absolute value will never equal negative 8. This isn't possible. Next up, we have the word asymptote, one of my favorites. It's an invisible line that a graph can get close to but doesn't touch or cross. People have asymptotes too. I'm sure you know people that have that line you don't cross, things that you can say or do that maybe trip temper or something like that or make them really crabby. That's an asymptote for a person. It's that line you don't cross. Well, with a graph, it's kind of the same idea. If I look at this sample graph, you'll notice that the way these little red branches, as they're called, are curving, it feels like they're trying to avoid certain lines on the graph paper. One of the lines it seems to be avoiding is this one right here, the y equals 3 line. It's like it's trying to get close to it, but it doesn't actually want to touch it. And same here, vertically, it looks like it's trying to avoid the x equals 2 line on the graph paper, where both sides are just getting closer and closer on either end, but they're not actually touching it. Those are asymptotes. A coefficient, that's just a number multiplied in front of a variable. But what you might not know is that a coefficient actually counts how many times a variable was added or how many times that it was present in a problem. That's a coefficient's job. It tracks addition, which means that anytime you change how many of something you have in a problem, your coefficient could change. So like 8x means 8 times x really just means there are 8 x's being added. So if I was using tiles, I would put 8x tiles on my mat because that's what it means. So anytime I change that quantity of x's, my coefficient's going to change. Next up is the cube root. The cube root of a number in geometry means the length of a cube when I tell you its volume. So it's like saying, I want a cube that can hold a certain amount of stuff. You tell me, how big should I make it? It's the value b that makes b cubed equal a, where b is the length of the cube and a is the volume. If I look in numbers, what it means is the cube root of 8 is 2, because 2 times 2 times 2 is 2 cubed, which gives me an answer of 8. If 8 is the volume, the length of the cube has to be 2 by 2 by 2. If the cube root of 27 is what I'm looking for, the answer is 3, because 3 times 3 times 3 is 3 cubed, which makes a volume of 27. Now, if I wanted a cube root of 20, we know that's going to be a decimal because if the cube root of 8 is 2 and the cube root of 27 is 3, 20 is in between 8 and 27, but closer to 27, just a little more than halfway. And so a little more than halfway between 2 and 3 would be about 2.7. If I plug the cube root of 20 into a calculator, I'll see that I was pretty close. Now, if I use the word cubic to describe something, it means that the highest power going on in the problem is 3. So in this case, it's x. The highest power of x is 3. Now, domain. The domain is all the values you can plug into a rule, and we are going to spend a lot of time looking at domain this year. So just as some early examples, if y equals 3x squared, the domain is anything. I can plug any number I want in for x if I was going to make a table for this. I could plug in positives, negatives, decimals, fractions, pi. I could plug in whatever I wanted. Now, if y equals 2 divided by x minus 3, my domain is everything except 3. Because if I tried to plug 3 in for x, I would get 0 in the denominator. And if you've ever asked Siri, you'll notice that dividing by 0 is not a good thing. You'll get some funny answers. In the world of math, I can't take the number 2 and divide it into 0 pieces. That just doesn't make sense. Now, if you want to be all super fancy about it, you could just say, well, x is just not equal to 3. Now, an equation. This is a mathematical statement that sets two quantities equal to each other. It has an equal sign. We usually solve it to get what x equals. Spotting the pattern here? So here's an example. There's that equal sign. Equations have left and right sides, where you're being told left and right have the same value. Can you now figure out what number I could plug in for x that would make the left and the right be equal? Which then brings us to another important word, equivalent. Equivalent in math means you have the same value but look different. So 5 equals 5 is really showing you that 5 and 5 are exactly the same. Duh. They're equal. When I say 2/3 equals 4/6, I'm really saying that 2/3 is equivalent to 4/6. While they have the same value, if we're talking pizza, 2/3 of a pizza and 4/6 of the pizza is the same amount of pizza, it still has a different look. 2/3 and 4/6 are different number comparisons. It's kind of like when I do money, a 10 and 2 5s is the same as a $20 bill. They have the same value, but they look different. Now, in the world of algebra, another thing we like to do is evaluate. This means to get the final value. Evaluate, get the value. So I might say, here's this little expression, negative 6x squared times y. Evaluate when x is negative 2 and y is 1. That just means plug those numbers into the right spot and get me a final value answer. That's evaluate. Now, an exponent. In the world of math, an exponent counts how many times something is multiplied to itself. Remember, a coefficient counts how many times something was added. Exponents count multiplications, which means that exponents only change when multiplication is going on. So 4 to the 5th means you're multiplying 4, the base, by itself 5 times. It's tracking that multiplication. It's a lazy way of saying 4 times 4 times 4 times 4 times 4. Now, an expression in the world of math, which is different from an equation, an expression is just a statement of numbers, variables, operations, all kinds of stuff. All you can really do is simplify it, if possible, but you can't actually solve it. There's no equal sign, like this one, no equal sign. If you wanted to get really kind of into the world of real life, let's say your parents ask you to clean your room. In all likelihood, your parents are asking you to solve an equation. They want you to get rid of trash, get rid of things that don't fit you anymore. They want you to solve and get it down to like this cleaned out, pretty place. Most likely, you hear clean my room as an expression. You don't actually change anything. You don't actually remove anything. You just reorganize it. Maybe you compress all your shirts into a drawer. Maybe you stuff everything under your bed. You've simplified, but you haven't actually solved the problem of too much stuff in your room. That's how it works in math. Expressions, no equal sign, no end result to accomplish, just something you can tidy up. Next up come two words that are very similar, but actually mean slightly different things. Intercept and intersect. Now, they're very similar in that both track a crossing place, but an intercept tracks where a graph crosses an axis, whereas an intersect tracks where two graphs cross each other. So here I've given you a graph, and Desmos is fabulous in that anytime there's an intercept or an intersect, you can click on it. So this graph had 3 intercepts, 2 on the x-axis at -1, 0, and 3, 0, and 1 on the y-axis at 0, 3. Now here, I have 2 lines that crossed each other. This is an intersect, 2, 5. The 2 graphs crossed each other. Now, I see a y-intercept here and a y-intercept here and an x-intercept down there, and looks like there'd probably be one way over there. But when I ask for an intersect point, I'm looking for where the 2 graphs are crossing each other. Intercepts are for axes. Now, when I do get those fun U-shapes, those are called parabolas. It's the U-shaped graph of a quadratic function, and they either open down, so like a rainbow, or they open up. So sometimes you could say this is a frowny face and this is a happy face. These are parabolas. Now, quadratic is any rule whose highest power of x is 2. So if I see an x squared, it's quadratic. And just for fun, I thought I'd throw in this word, quartic. That's where the highest power is 4. That's just fun to say. Now, we talked about domain earlier. Now let's talk about range. Domain is everything you plug in. Range is everything that comes out. So when y equals 3x squared, I can plug anything I want in for x. Anything. Dramatic thunder. Anything can go in. But when I square a number, it always comes out positive. And that's a positive 3. That means that no matter what I plug in for x, it's always coming out as a positive answer. So the range is any positive number, or I could write y is greater than or equal to 0 to be like math fancy lazy. With this rule, y equals 2 over x minus 3, the range is everything but 0. Because the thing is, no matter what I plug in for x, I'm always dividing 2 by a number. Well, if I'm taking 2 and dividing it by anything, I'm not going to get 0. The only way to get 0 when I divide is if I was doing 0 divided by something, if the top was 0. So no matter what, this thing's never gonna get to 0 as an answer. And so I could say y not equal to 0. All right, now here come 2 other words that are important. The idea of simplifying and solving. Simplifying is making it smaller, easier, or more compact. So simplifying your room is to just stuff things in places that makes it look cleaner. Nothing actually goes away, it just ends up smaller. Like here, if I have all of these things, I can combine the like terms, I can make it smaller, but I don't actually get anywhere. Solving is when you can get down to a final answer. So when your parents say clean your room, they're really asking you to solve to produce something that's super neat, tidy, clean, and everything else. There's an end goal in mind. Solving would be like this. The answer is 4 because 4 is what makes this statement left side equal right side. Next up, we have square root. We did cube root. Let's go to make sure we get square root too. A square root says, tell me the length of a square if I give you the area. The value b that makes b squared equal a, where b is the length of the square and a is the area of the square. So the square root of 9 is 3 because 3 times 3, which is 3 squared, makes 9. If I want a square with an area of 9, I need to make it 3 by 3. Square root of 16 is 4 because 4 times 4 is 4 squared, which is 16. If the area is 16, the length of the square would have to be 4 to make it work. So then if I want the square root of 11, well, 11's between 9 and 16, but definitely much closer to 9. And so then its square root has to be between 3 and 4, but definitely much closer to 3. So you might guess like 3.2 or 3.3. And last but not least, we have the vertex. The vertex of any graph
is a place where it changes shape or direction. Well, basically where it changes direction. Sometimes it's called a corner. Sometimes it's a highest or lowest place. But if I look here on this V-shaped graph, which is from absolute value, it has a vertex because right down here it has this point where it was heading down and then it turns around and heads back up. That's at 4, 1, so that's its vertex. This parabola was heading up in a nice little rainbow, reached this like top point, and then started to head back down the same kind of way. That's also a vertex. It changed direction. It's not quite a corner, and it's not quite pointy, but it's definitely a high-low place, in this case, a highest place. So this is your basic math vocabulary. Trust me, there's a lot more, but this at least gets you a good start for Algebra 1.